Hey, my name is Anton. Welcome back to Echo Aircraft. Now, today's video, as you've probably seen, is not really aircraft related, but it is aerospace. So while recently browsing through YouTube, I saw a whole bunch of videos of people building their own Mars rovers. And I became greatly inspired by the simplicity and effectiveness of the rocker bogie suspension mechanism. And I also saw this video of this guy building different vehicles for different terrains out of Legos. And for sand, he decided to use Mars Rover Perseverance wheels out of a Perseverance Lego set, and that got me so inspired to build one of my own. Now, for the majority of the project I decided to use 3D printing, mainly because I had so much leftover filament. I bought like 3 rolls of this ABS 3 years ago, and I never used it. And ABS sucks as a filament to print with, but it's pretty strong, so I'm hoping for that. I thought the project would be fairly easy, but I was quickly proven wrong by the complexity and different caveats that came with the project. So, join me on what became a more than a month-long journey from design start to final completion of me building my own Mars rover. So, let's go. I quickly dropped the design of the rover in my head. I knew it was gonna be similar to a Perseverance rover with a rocker bogie suspension, have 6 wheels, have a functional FPV camera with a pan and tilt servo, and also feature a gripper for picking up small objects. My goal was to be able to perform simple missions with the gripper and the FPV camera, and to roleplay as a NASA scientist like I know what I'm doing. Here you can see the progression of the rover in CAD. I wish it was that fast to design it, but honestly the design process was one of the most fun parts of the entire project, especially trying to design all the moving components. Usually my 3D designs are not nearly as complex and detailed, just because usually I make my airplanes by hand, but in this case I had to design everything to be perfectly fitting together because it's all going to be printed. The biggest challenge during the entire project was definitely designing all the moving parts and mechanisms, just because I don't have any experience designing them. The simple arm, as you can see, moves up and down with a gripper that somewhat moves, but it actually does move in real life. The camera pan servo uses a gear ratio to increase the range, and there's also a servo for pan. The most complex thing to rig up was the rocker bogie suspension, but after making sure it works, it was time to print out all the parts. Like I said before, ABS is a pain to print with, so I had to build this full enclosure just so I get somewhat decent parts. Each batch took about 8 to 12 hours to complete. Over here you can see all the parts that I needed to print out. It was really a whole lot of parts. The whole did not turn out as good as I expected. There was a lot of warping despite the print being in an enclosure, so I ended up fixing it with an old soldering iron and a bunch of filament. The hatches are all magnetically held in, and the whole rover is ready to be assembled. The off-road capabilities of the rover are defined by its suspension system. It consists of a rocker bogie suspension, which you can see me assemble in this frame. We got a motor in the front, in the rear, and the middle is left unmotorized, which then turned out to be not the best idea. I had to sand down the wood pieces that went in between the parts just because of the tolerances, and I'm using some CA glue to fix them in place. The parts go in pretty tightly, so you might not even have to use CA glue and just rely on friction fit. I am now screwing the final assembly of the rocker arm together to be then assembled onto the rover body. Here I'm making a mirrored version of the suspension arm to be put on the right side. The suspension parts don't move by themselves, so I'm adding this rocker link to connect the two sides together. I had to do some drilling and grinding to allow the suspension arms to move freely. I have to say, putting the suspension arms into the rover was kinda a pain, so I would probably have to redesign the way it's attached. Using some smaller screws, I connected the rocker link to the suspension arms and now the entire mechanism moves in unison. CA glue is used to fix the joints in place after adjusting their position. As we can see now, the rocker bogie suspension is assembled and working. This kind of suspension allows for the highest travel while keeping the most wheels on the ground, providing superior traction and stability. Here I am soldering the wires onto the motors while color coding them for each side. All the motors are now in place, and it's finally time to put it all together and test it. But I was met with a surprise. So I just realized my grave mistake. I always thought that this module was supposed to be running on PWM signal, but no, it's an Arduino based module, so it runs off a 0 to 5 volt logic. So I ended up completely rewiring the whole thing, this mess. I actually had two of those ESCs for brushed motors, which use an actual PWM signal right here. And then also I have this huge 2-cell battery, 5500 milliamps. So that should be enough to power the whole thing, because those ESCs only take 2 cells. Alright, it looks like a big mess of wires right now, but after some setup, look at this. Everything goes forward, reverse, and I can also steer it. Alright, I packed all the electronics in, at least for now, and it's looking pretty good when it's all closed up. Alright. Now here's the part everyone was waiting for, the wheels. The wheels go snugly on the motor shafts and are secured with some screws that came with the servos. Man, those wheels look amazing on that thing. I can't wait to actually put on all the add-ons here that I can put on to actually drive it around and drive it like FPV. But for now, let's do some ground tests.
Welcome on board, Captain.
Alright, let's go. Forward. Reverse. Alright. Turn. Oh, it's so cool. Okay. Forward. And turn at the same time. Now that I made sure the rover actually drives and works, it's time to put on the camera gimbal and the gripper arm. I have to say, I am very new to designing good mechanisms, so it was kinda difficult to put them together, but in the end, it ended up working. Here you can see how a gear ratio increases the range on which I can turn the camera. Here you can see me struggling to put together a functional gripper arm, just like I struggled to design one. The parts would not fit together, and the poor ABS print quality would also add to the problem. But in the end, after some grinding and drilling, it seems like the arm started working. Now that I made sure that all components are working as they should, I am putting them on the rover to complete the final assembly. Have to say, wiring this thing was not as hard as I thought it would be, just due to the cramped space. It was a little bit tricky. I ended up taking up all 6 channels on my FlySky, which ended up being just enough for what I needed. And here it is, finally turned on and assembled. The video transmitter is being cooled by a small fan from a tiny whoop, and the camera has a spotlight on it. The camera gimbal can tilt down, up, and also rotate almost 360 degrees, which is perfectly enough to get a good look at the surroundings. The gripper arm has enough range, and the gripper itself has a pretty good grip. And so, at around 5 AM, the rover was finally assembled. Now let's go and give it some tests. At 5 AM it was still too dark outside, so I decided to run some tests in the living room. Let's see how the rover performs the simple mission of picking up a battery. Placing it back down is also not an issue. I stayed up till like 6 AM that night. I was trying to perfect the design, make sure everything worked, and it did. The camera worked really well, the gimbal worked, and the gripper worked perfectly fine. I was able to perform some small missions around my living room and I couldn't be happier. But the rover was never built for a living room. It was supposed to be an outside rugged vehicle. So, I went out and tested it in some elements.
Yeah, that looks cool.
Alright, it's in the fort. I'm gonna see if I can get into that island.
Yes!
Oh, it's so capable. I never mentioned that the rover has a name, TARV-M, which stands for Terrain Articulated Rugged Vehicle Modular. I think that name has a good ring to it, and fits the rover really well.
It's so cool!
The rover ended up performing quite well, but due to the middle wheels not being motorized, they ended up dragging more than actually helping the climb performance, which was to be expected. I don't know why I thought it would be a good idea to make it only a 4-wheel drive instead of a 6, so I ended up ordering more motors. After the final assembly was complete, the rover was now a 6-wheel drive, and it worked really well. Let's test it in some elements. After being converted to 6-wheel drive, the rover became practically unstoppable. So as a real stress test, I decided to send it through the stick bog. The rover almost got stuck in the stick mud, but with the motors spinning and grinding and begging for mercy, the rover still pushed through. I was very happy that I didn't have to go into the mud myself to pull it out. After conquering the swamp, there was so much mud on the wheels, but after I made sure the rover won't fall apart, I headed to an awesome testing ground that I found near my house. This place closely resembles the Mars yard at NASA's JPL, and it was a perfect place to test my rover. I also felt like it was a wise decision to put an orange filter over the footage. That way the rover feels more at home. With many of my designs, usability comes first, so I built this rover to have a camera and a gripper in it, so I could drive out, pick out some small specimen and bring it back to me, over any terrain, practically. So, I'm going to set myself up a little challenge. There's a pile of Martian rock that I need to pick up. And to get there, I need to drive around the crater, through the sand, starting from right there, let's say. And I'll have to do it all using FPV goggles. Let's try it. And so, the challenge was on. I tested all my systems to make sure we're good. Gimbal, go. Arm, go. Motors, go. We're good to start driving. The rover began to struggle through some thick sand, mostly due to the mud that's caked on the wheels, but I never touched it, and I let the rover find its own way. After the sand was behind us and some denser dirt came, the rover performed in its prime. It had no issue climbing hills and navigating through complex terrain. At this point, I was afraid that I bottomed out the rover, but I actually had tons of clearance left. I decided to take a break and admire this beautiful Martian crater. I'm not going to go in there because I'll get stuck there forever. I decided to take a closer look and almost got one of the wheels stuck on the rim of the crater. Fortunately, I was able to drive out. I was so close to my goal, but the rover ended up slipping off the edge of the cliff. But with 6 motors and 6 wheels, it climbed and crawled all the way back up to the top. This is it, the moment of truth. I have to be very careful with the manipulator in order to grab the top piece only without knocking over the tower. It is very hard to judge the distance in the FPV camera, so I had to make several attempts. TARV-M, go for capture. It looked like it was there on camera, but it actually wasn't. After readjusting, I went for another capture. Go for second capture, TARV-M. And finally, the specimen was successfully acquired. We got a nice chunk of Martian dirt. Now I have to drive it all the way back without damaging or dropping it. I will then put it in some water to make sure that it was an actual piece of dirt and not just a rock. I am aware that there's not nearly enough water on Mars to form a creek, but my Mars can be whatever I want it to be. So this one has a creek, don't question it. Driving back the rover had no issue going over the complex terrain, and it actually felt fast. My favorite part of the rover experience is driving through sand. I love seeing how the suspension articulates and how all 6 wheels are trying to plow their way through some thick sand. I was kinda worried driving the rover in the water, but then I realized that the motors are actually way higher than the wheels are, so as long as I don't exceed that height, I should be fine. I carefully placed the specimen into the water, made sure to dip the servo in the water by accident, and then I decided to drive over it to see if it's going to disappear. After seeing a cloud of dust come out, I knew that it was indeed just compacted dirt and not a rock. With a successful experiment, the scientific mission was finished. Alright, this rover is awesome. As you can see, I got so much mud all over it, but all wheels, despite the strain and the stress that they took, they still work perfectly fine. And the rover had no trouble climbing over rocks, climbing onto hills, climbing through sand, through mud, through dirt, through small rocks, through anything you throw at it. I was so surprised by how well this little thing performed for its size. This is definitely my proudest creation of all time, and I couldn't be happier. The project took about a month, maybe more than a month, from design to the final completion, but it was totally worth it for all it took. And because M in TARV-M stands for modular, I plan to expand on the rover a little bit. I can always design a better arm, I can always design a better gimbal, I can design something that will work in a fully different way anyways. So this rover has pretty much endless possibilities for upgrades and new applications. So at this point, if you like this rover and you think my efforts are worth supporting, please leave the video a thumbs up because that really helps me build the channel. And also sometimes I upload things like that, which are pretty cool, so you can subscribe too while you're at it. I post some pretty cool stuff, even though it's not that often. Alright, so at that point, I think I will say bye-bye, and I'll see you in the next video. Later.